This is Pre-Calculus Concept 7E. We're going to talk about odd and even functions. 5 boxes on this one. So the mathematical definition for an odd and even function is below. If you have a function that is odd, that means that f of negative x equals negative f of x. All right, this will be more clear with an example. A lot of people think that negative sign can just be pulled out like that, but it can't be done. But if those are equivalent, we've got a special situation of an odd function. And a function is even if f of negative x equals f of x. Right? So a good way to think about this one is, what happens when I stick in negative x? Do I get something that's the exact opposite of what I started with? Or do I get the exact same thing that I had in the first place? And if it's the first one, then it's odd, and the second one it's even, and then many times it's neither. So we'll look at an example of neither as well. Alright, so for each of these we're going to do a little test. We're going to think about what f of negative x is equal to. So just like before, we're thinking of negative x as our input. I'm going to do 3 times negative x squared, and then I'm going to simplify this expression, and I get 3 negative x times negative x is positive x squared. So I started with f of x equals 3x squared. I plugged in negative x, but the result was the exact same thing that I started with. That makes this an even function, so you can conclude after that test that you found an even function. Alright, let's try the second one. F of negative x, right, is going to be negative x cubed minus negative x. When I have a negative times a negative times a negative, it's going to be a negative answer. And then here I have a negative negative, which is plus x. And so when I compare my answer to my original, they're exact opposites of each other. So this is actually the opposite of what I started with. And that makes it a odd function. So number 2 is an odd function. Alright, let's try the third one. If I look at this one and I take p of, I used f up there, sorry, it should have been g. P of negative x, then I get negative x to the third plus negative x squared. And simplification gives me negative x cubed plus negative x times negative x is positive x squared. Alright, and so now I want to compare my answer to my original. They're definitely not the same. And while a piece of it is the opposite, it's not overall the opposite, right? Hopefully you can see that. I would have to have a negative negative down here for it to be the exact opposite. So this is an example of a function that is neither. It is not odd or even. So many functions are neither. The odd or even just comes up in some special cases. Alright, let's have you give it a try. Here's a function. I want you to tell me if it's odd, even, or neither. Think about the test that was done in the previous examples. Alright, hopefully you got that this was an odd function. When you stick in negative x to the function, simplify, you end up with this expression, which is the exact opposite of what you started with. And that makes it an odd function. Alright, the concept of odd and even is actually very clear if you think about things in a graphical way, because odd functions have a very special kind of symmetry, and even functions have a very special kind of symmetry. So we'll start with the odd functions. Here's 2 examples of odd functions, and hopefully you can see that there's a special property here. And what it is that if you took this graph and you spun it exactly 180 degrees, you would get the same exact graph. And that has 2 names. One of them is, sorry, let me write that again, 180 symmetry. Because again, if you spin the graph 180 degrees, you get the same thing. It's also called origin symmetry because you are basically turning the graph around the origin as a central point. If looked at the second graph and I spun it 180 degrees, you can see that those 2 points would be interchanged, but you'd get a graph that was exactly the same as the original. So if a graph has origin symmetry, okay, or another way of naming that is 180-degree symmetry, then it is an odd function. So if you just look at a graph, you should be able to tell that right away. It does have to be centered at the origin, very important. All right, if I look at the bottom two graphs, there's a different kind of symmetry. This is kind of a mirror image. So if I drew a line right down the middle, hopefully you can see that the right side and the left side of this graph are exact matches. And same thing on the second example. If I drew a line right down the middle, you could basically fold the paper in half and you would get the graph to match up. So this has a special name called y-axis symmetry. And all even functions have y-axis symmetry. So that's a quick and pretty easy way to determine odd and even if you are looking at a picture. Again, odd functions have origin symmetry, and even functions have y-axis symmetry. All right, so this is one for you to try. The function shown below is something we're going to study later in the year. It's called the sine function. Some of you may have seen it. See if you can look at this and tell whether it's odd, even, or neither, and why you came up with your answer. Okay, hopefully you came up with odd. This graph is an odd function because it has that origin symmetry. If you imagine spinning it 180 degrees, this point would go to this point and vice versa, and the graph would be the same if you spun it 180 degrees.